A multiple regression equation was found to be y hat equals 0.179 plus 0.022 x sub 1 plus 0.128 x sub 2 minus 0.312 x sub 3. Perform a global test to determine whether it is possible that all the independent variables have zero coefficients. So just a review of what this was. In a previous video in this series, we were talking about trying to predict the a stock's gain or loss on a given day by taking its previous day information. And I just had three variables, three independent variables. It was previous day's percent change, previous day's high as a percent of close, and previous day's low as a percent of close. And those three variables make up the x sub 1, x sub 2, and x sub 3. And you see these coefficients here, and as well as the intercept, 0.01 or 0.179. So in that video, in that previous video, I said, well, you know, if this were easy, if that equation were surefire, of course, I would already be doing it. And a lot of people would love to do that, to just be able to take some information from yesterday and guess pretty reliably what the stock prices are going to do. So we're going to do a global test to see if it's possible that just we don't have enough data. You know, we got these numbers, but maybe if you had more and more data, you would actually find these coefficients to be zero, just meaningless. And the intercept might change as well. So let's do that global test. And that works with the old null and alternative hypotheses. So the null is that beta now. So with these coefficients, we talked about these as b sub 1 and b sub 2 and b sub 3. And just like the mean is x bar and that's the sample mean, and the population mean is mu. Well, with the multiple regression equation, you have b as our best guess. Think of it as the x bar, and then beta sub 1 is the true coefficient. If we had all of the population of all the stocks ever and all the stocks ever that will occur on trading days. So here's the global test. Beta sub 1 is equal to beta sub 2 is equal to beta sub 3 is equal to 0. So they actually have no bearing. There's no coefficient on any of the variables. So the variables are meaningless for prediction. Or the alternative that would say at least one of these is not 0, or not all coefficients are 0. So we have these opposing ideas, as we do in the null and alternative hypotheses with all hypothesis tests. So the next step is to find the p-value. And the p-value is actually taken from an F statistic. Well, in the previous video, we did this data analysis on regression, and we found these tables as part of the summary. We got the coefficients. We didn't talk about before, but we'll talk about now, this F statistic, and then the significance F. Well, guess what? I know a lot of times books will talk about taking this formula and looking it up in a table, but Excel gives you the p-value right here. It doesn't call it the p-value, but that's what the significance F is. And it's this area to the right of an F value of 2.46 with these degrees of freedom of 3 and 135 degrees of freedom. But we know where we have this p-value right here, so I'm just going to write it. P-value equals 0.065, which is unfortunately greater than. If you're not given an alpha, a significance level, then you can assume that it's just 0.05. And when a p-value is greater than the significance level, then we fail to reject the null. unfortunately, and there's the drop in my voice because that means that we can't necessarily use this equation to reliably predict what stocks are going to do the next day. Because if we fail to reject the null, that means that we're kind of siding with this. We're saying, hey, well, we can't say this is not true. We never say it is true. We never say we accept the null, but we're not rejecting it. We're saying, well, it's possible. It's possible that this is true, that all of these coefficients are 0, and we can't even make a prediction. So that's what we say in our conclusion at the end, is that it's possible, or not enough evidence. We can say there's not enough evidence to say that at least one coefficient is not 0. Sounds like a lot of double negatives there, but that's the way we write it, the way we say it in statistics. Not enough evidence to suggest that at least one beta is not equal to 0, so that it does hold some weight. I know what you're thinking here. This p-value, hey, it's pretty close to 0.05, and maybe with more data it would get even lower. That's possible. That's possible. It might get higher also. We might find these coefficients getting closer and closer to 0 with more data. I'll leave that up to you. You can perform this, get even more data than we have in this sample, and see what happens. Maybe you can find a prediction. If you do, write to StraighterLine. Let me know about it, because I'd love to be able to predict the stock market.